Hi guys, in today's video we are working on composite functions. We want to check if which one of these is even or odd. We have the function fog of x, gog of x, gof of x, and even the product function fg of x. How do we determine if this function is even or odd depending on the question given to us? Before you tackle this one, I recommend you look at my videos for even and odd functions. There is a separate one for even functions and there is another one for odd function. Locate these videos in this same playlist. This will give you a basic background of how to handle even and odd functions before you tackle this example. So now I will brief you in just some few seconds of even and odd functions. When you look at this very carefully, I have a function here which is fog, which is the same as fog of x. Fog is the same as what? Fog of x. It simply means that the function f of x composite g of x. Now this zero you are seeing here is a small circle known as the composite symbol. So f composite g means f of x function into what? The g of x function. You can rewrite this in this form. The f of x function, remember that as you write the first function, you do not indicate the variable x into a square bracket, the g of x function. That is what we have here. So this is called the outer function, and then the second one, which is g of x, is known as the inner function. So when you look at my video also under composite functions, you understand this concept. Before I begin, please subscribe to this channel. Just take a few seconds to do that, just to support this page. And you can also click on the notification bell for further updates. So let's see what we have. All right, so now that we know that fog is the same as fog of x, let's focus here and solve this. So our fog of x can be written as the outer function containing the inner function g of x. Now, before we start, we would have to go back to the question and read the instruction very carefully. The question says that if the functions f of x and g of x are respectively odd and even, this means that the first function is an odd function. That is the instruction that was given to you. And g of x is an even function. This thing can turn depending on the way the question appears. The question can say this is even, this is odd, or this is odd, this is even. In this concept, the question is telling us that f of x is odd and g of x is even. Then it says determine whether the following are even or odd. So we have four different functions here. Now, we need to write down that statement before I start this calculation. So first, the question says that f of x is odd. So if f of x is odd, then for odd functions, anytime you text with a negative x, the result generates a negative what? Result. So f of negative x will give us minus f of x. This is the rule for odd functions. Then it says that g of x is even. So we write g of x is even. Then for even functions, anytime you test with a negative x, the result is a positive function. So g of negative x will give us g of what? X. So this is the rule that you need to put in your mind. Remember, any of these functions can be said to be even or odd. So the rule is if it is an odd function, then the negative of that function will generate a negative result. If it is an even function, the negative of that function will generate what? A positive result. So from this principle, we can now solve the question. So let's continue from here. Now, we test this result with a negative x. Then we have fog of minus x giving us f into g of negative x. Okay, so now we substitute negative x inside. Then what happens? We have fog of negative x is giving us, then we go back to our rule. What is g of negative x? G of negative x is the same as what? g of x because the g of x function is an even function. So wherever we see g of negative x, we substitute what? G of x. So I replace that by getting f into g of x, bracket close. Now f into g of x is now similar to this one, which is the same as fork of x. So we have fork of negative x is equal to fork of x. All right, so now if fork of negative x equal to fork of x, then the function is an even function, because when we tested with a negative x, the result was still the same positive function. So this is an even function. So you write your last statement by saying, since fork of negative x equal to fork of x, the function is an even function. Okay, so that is my final answer. Let's move on to the next one, gog of x. Now, the function gog, which is g of g, is the same as gog of x. And we can rewrite gog of x the same way we did the first one, as the outer function g into the inner function g of x. Okay, this is very simple for everyone to do. Now, when we get here, we test this result with a negative x. Then we have gog of minus x equal to g into g of negative x. Okay, now we go back to our rule. I was supposed to write this on. So what is g of negative x? G of negative x generates the result g of x, because g of x is an even function. So wherever we see this one here, we substitute what? G of x. So we have gog of negative x is giving us what? G into bracket g of x. Now this result is the same as gog of x. So gog of negative x is gog of x, which is an even function. Why? Because when we test with a negative result, we are getting the same original equation, which is still what? A positive function. So this is an even function. So we write the same statement. So the statement by saying that since gog of negative x, which is this, is equal to gog of x, it shows that gog of x, the main function given to us, is an even function. So you leave it here. So the third function, we have fg. Fg is a product function. It is not a composite function. Okay, two product functions, f of x and g of x. So for the product function, fg is the same as the fg of x. Okay, two product functions, and it means the f of x function multiplying the g of x function. So all you need to do is to separate it. So this is gonna give us the f of x times the g of x function. Now when you get here, you know what to do. All you need to do is to test the result with a negative x. So testing with negative x, we have fg of negative x giving us f of negative x times g of negative x. Now, in the beginning, we learned that the function f of x is odd and the function g of x is even. So, from analysis, which is what I have here, this is odd, which is f of x. We already know. So, now, wherever we see f of negative x, we substitute what? Minus f of x. Wherever we see g of negative x, we substitute what? G of x, since g of x is what? Even. So, this is giving us minus f of x times g of what? X. The result is going to give us minus fg of what? X. So now the fg of negative x is equal to what? Minus fg of x. And this is an odd function. Remember, all odd functions are generating a negative result. Okay, so now you write your final statement by saying that since fg of negative x generated minus fg of x, it shows that fg of x is an odd function. So this is for product function. Let's see what we have for the next question. Okay, so now from here, we rewrite this as the outer function g of x into f of x. Remember, when you are writing the outer function, you don't need to indicate the x. We don't indicate the x, okay? Now, we test this with a negative x. Then we have gov of minus x equal to g of f of negative x. Now, listen to me and get this once and for all. This will generate an even function, and the way I am going to do it, if you don't get it, you will always get confused. Now, let's go back to our rule and see what will happen. When you look at this, what is f of negative x? It is negative f of x, because when we test with a negative x, this is the result. So we replace this with what? This into the function, and let's see what will happen. Don't forget the f of x function is odd. That is why we are getting this. So wherever we see f of negative x, we put minus f of x. So we have gov of negative x giving us g into minus f of x. I guess you understand up to this point. Now listen to me. You do not bring out this negative to say it is an odd function until you check. Okay? So when we get here, this g of x function is going to eat up this negative value, making the function even. Why am I saying g of x is going to eat up this thing? Let's go back to the rule. Locate the g of x function, which is here. This g of x function is an even function. And anytime we test an even function with a negative value, the result is always a positive result. So, assuming this f of x here is representing a negative value like what we have here, a negative variable, then it will eat up the negative sign and generate a positive result. Do you get it? I repeat, this g of x function is an even function. And when you test an even function with a negative function, which is negative x, you generate what? A positive result, which is what? The same g of x. In the same way, when we come here, we cannot bring out this negative until we check if this function is even or odd. And because this function is an even function, it will eat up this negative sign and generate what? G of f of x. So in your next step, this is the same as g of what? F of what? X. And g of f of x is the same as what? Gov of x, which is equal to gov of negative what? X. And this is an even function. So let me write that statement. So gov of negative x was equal to gov of x. The result is an even function. You leave your answer here. Now, in the part 2 of this same video, I am going to take the same function, but this time I will turn this one and make f of x even and g of x odd. Then we see the result and check which one of the function will be even or what? Odd, so that you do not get confused because of this side. Because if the question is twisted, students find themselves in trouble. So I'm going to take 2 different examples. So meet me in the next video of showing if a function is even or odd, part 2. See you in the next one.